Good morning, everyone. Can you hear me clearly?
Yes.
Yes, teachers.
Yes.
Okay, so right now, is this your slides move? Right now, is it outline?
Yes.
Is it, so this is the first lecture. So first of all, Happy New Year for the year 2022, and I could like to say I'm very happy to be here and um, nice to meet all of you here. And right now we become the partner during this course. And thank you for joining my lecture. So it is probabilities and statistics. I think it is quite hard course for all of the students in the university. So I hope that all of you will have the higher point overall this course. So for the first lectures, introduction to descriptive statistics. So for these lectures, I will introduce the course objective and requirement, introduce statistics and its application, and number 3 and number 4 is the main knowledge for the first lecture. You have to describe all types of data, way to collecting, and we introduce graphical methods for describing data for one variable. Actually, the purpose of statistics for business and economics is to give the student primary data in the fields of business, administration, and economics. A conceptual induction to the fields of the statistics and its many applications. So for this course, we introduce the basics, probability, and statistical methods. We will discuss how to apply statistic technique in practical situations. And as you know, that we will have the report for the course. And this is the reasons why you have to work on a small scale project to gain data analysis experience. And this is the time for you to practice. You can learn how to use the statistical software, and it is R software R's, a software to collect the data and help you to interpret. So the course outline, you have to read the course outline carefully. You have the lecture notes and tutorials, exercise, and the book in Google Classroom, right? So is contained important information of the course and assessment attendance 10%, but maybe for my lecture I will not check the attendance, but sometimes I will give you some small tests, so I can check the attendance based on the point for your small test. Okay, and the project 20% for tutorials class. The lecturers will divide all of you into some small group, and you can make the project together. And midterm 20%. So all of the knowledge of this lecture of this line I just tell you before, right? You can follow some posts in the Google Classroom to get the information from this course. I do know that the probability and statistics course based on the knowledge of mathematics, economics, business, right? And it is quite hard course. So we could like to give you some recommended study strategy. Discuss lecture notes with your peer, review your lecture notes weekly, attempt on the tutorial exercise is very important because when you do some problem in the tutorials list, maybe you don't know is correct or not, right? Participate in class, ask question, contribute idea, volunteer to present solution, and take note. Read the assigned reading in textbook and work actively on your projects and the lab. Do further reading if you have times. But I think 1 hour, maybe 30 minutes to 1 hour is it enough for you to practice on the problem for PAS in every week. Yeah, I think 30 minutes is at least 30 minutes and maximum 1 hour per week is enough. Okay, so the question in here is what is the statistics and why we have to learn this course? How is applied to your real life or to your majors? So statistics is defined as the art and science of collecting, analyzing, and interpreting data, particularly in business and economics. The information provided of collecting, analyzing, presenting, and interpreting data give managers and decision makers a better understanding of the business and economic environment, and thus enable them to make more informed and better decisions. Okay, so follow some step in here. When you collect the data, you can know exactly about your population, maybe the height or the weight of the student in the first years of Hanu, for example, right? When you collect data, you can you can make some decisions or some information from your data. So data is the facts and figure collected. Statistic is either science of data involving collecting, classifying, summarizing, organizing, analyzing, and interpreting data. And all the data collected in a particular study are referred to as the data set for the study. So for the statistical methods, we have two main parts. The first one, when you collect the data, you have to descriptive statistic. You descriptive information from your data you collected, and after that, from the data, you make some estimate, you make some hypothesis, and it's called inferential statistic. So we have to base on two main parts for the statistical methods. So for descriptive statistics, so for the next, I will explain what is descriptive and what is inferential statistic. So for descriptive statistic, when you look at to the graph, right, you can see that in here the revenue for 8 years. No. It's not for 8 years. It's for Q1, Q2, Q3, and Q4. For eight areas can Lincoln measures and jog. So such summaries of data which may be tabular, graphical, or numerals are referred to as descriptive statistics. So here's some step when you involve this descriptive statistic. So the main knowledge for descriptive statistic is that when you collect the data, you have clean the data, and after that, and present it by using some table. And for the second branch, it is inferential statistics. Statistics use data from a sample. Statistics use data from a smaller group to make estimate and test hypotheses about the characteristics of a population through a process referred to as statistic inference. Why we have to use the data from the smaller group? Because maybe we could like to find the height for the student in Hanu, for example. But it's very hard for you to collect all the data from each student in Hanu, right? So maybe we can collect 100 people, and after that, use the data from the smaller group to estimate. To predict or estimate behind for the whole population, for the whole group. So it is inferential statistic. So most of the statistical information in newspaper, magazine, company reports, and other applications consists of data that are summarized and represented in a form that is easy for the reader to understand, right? So such summaries of data, which may be graphical or numerical, are referred to as descriptive statistics. And for the second step, very important, inferential statistics utilize sample data. The smaller group. It's a smaller group data to make estimate, decision, prediction, or other generalization about the larger set of data. So right now, I will give you some basic definition and the concept. We have find new word for all of you in here. The first one is population. It is a set of own unit. The variable is its characteristics or properties of an individual population unit. And sample is a subset of unit of a population. Measurement assigning number to object, and observation is a set of measurement obtained for a particular element. Okay, so I think we will have the we will have the example in here for you to understand each word in here. So actually, many situations require info about the latter group of element, but because of high cost and other considerations, data can be collected from only a smaller part of the group. So latter group of element in a particular study is called the population, and the smaller group is called the sample. So when I give you an example in here, so can you help me to define which is population and which is sample? Maybe I have an example. Can you see my slide clearly?
Yes.
Thank you so much. For example, I could like to find the average talking time, talking time. Average. average talking time for the smartphone. For the smartphone of the student in the Hanu. And I could like to find the average of talking time for the smartphone of the student in Hanu, but I just collect the information from 300 students in FMT faculty. Okay, so what is the population and what is the sample in here, class? I could like to find the average talking time for the smartphones of the student in Hanu, but because of time, the course, and other considerations, only me collect the data, and it's very hard for you to collect all those the hours of every student in Hanu. So I just collect from the data from 300 students from FMT faculty. So what is the population in here?
The students in Hanu.
Yes, the population is the whole group. Is the latter group, right? And what about the sample?
300 students in FMT.
Yes, so it is the difference between population and sample. And for the statistic, we just use the data from the sample, I mean the smaller group, and use that data to interpret, to predict, or to estimate the average for the whole group. Okay, and the variable in here is the characteristics or properties of an individual population unit. And in this example, the variable in here is the talking times. Variable in here is the talking times. And the measurement. The measurement is a scale to measure the variable. So the measurement in here maybe is the variable in here when I adduce how much time you spend for talking by smartphone, right? So the measurement in here maybe is this hour or is this the unit minutes, yeah. And the observation it is the set of measurement obtained for particular element. And in this case, observation is the name or is this X student from your sample. So is this clear to you? For some word in here, 5 word, new word, population, variable, sample, measurement, and observation.
Yes.
Okay, thank you so much.
Yes.
Okay, so we have another example. If we are interested in the number of hours per day, the average high school Vietnamese students spend sending text messages, work in pairs, okay, work by yourself, and answer the following questions. What could be the population? Class, what could be the population?
High school Vietnamese student.
Yeah, high school Vietnamese student. So why could a sample be necessary? Can you collect all the data from high school Vietnamese student?
No.
No.
It's too hard.
Yeah, is this impossible, right? So this is the reasons why we have to collect the data from a smaller group. Maybe you will ask 10 or 5 students for each high school from Vietnam, right? And after that, use that information to estimate, to predict the average hours sending messages for all the Vietnamese student. And what could be the variable of interest? What is the variable in here?
Sending text
Sending
message
text.
time.
Sending text message times, okay? Or is it the number of hours per day sending text message? So is it some basics definition for statistic? Population, sample, variable. So data can be classified as either. We have two types. The first one is categorical, and the second one is quantitative. Quantitative or numerical, or is it a number like that? And qualitative is it or categorical. So data can be grouped by specific category are referred to as category data. And data that's numeric values to indicate how much or how many are referred to as quantitative data. So we have the question. I know we have the example first. Look back to the example in here. So what kind of data in this example? What kind of data in this example? Quantitative or qualitative?
Quantitative.
Quantitative.
Quantitative. Or is this a number? Right. Because we focus on the number of hours per day. See? And let's I give you an example for qualitative. For qualitative, when you rating for the qualities of the hotel, for example, maybe is it excellent, good, or poor, right? So in this case, it is qualitative because you can measure, right? Because in this case, it is not the number, so it is qualitative. What is the genders? For example, genders. Is this maybe boy or girl? Right. It's not the number, so it is qualitative or categorical. So the question in here is: are there number that are not quantitative? Are there number that are not quantitative? Yes or no?
Yes.
Yes. Where? When? So when customer provide a repair service ratings of excellent, we have three options: excellent, good, or poor. We may use the numeric code. We use the code by letting one denotes excellent, two denotes good, and three denotes for poor. So in this case, the numeric values, when you look at the data set, it is 1, 2, 3, 3, 2, 1, for examples. So in this case, the numeric values 1, 2, 3 identify the categories of quality. So the data in qualitative even true is appear as numeric value. Sometimes we use the number to denote for excellent for variable of qualitative. So sometimes it appears as a numeric value, but it is not quantitative. Any question? Class? Is there any question here?
Can you explain again?
For the example.
Vâng ạ.
Okay, so for the example in here, when the customer provide a rating for the qualities of service, for examples, and we have three options in here: excellent, good, and poor. But it's very hard for you, and it spend a lot of times when I have to spend time to write excellent, good, or poor. So in my in my in my in my collection, I say Hương, for example, Hương say one, Hùng say two, and Linh say three, Hoa say one, for example. When you look at to the data, it is like that. So in this case, the numeric values 1, 2, 3 identify the category. It's not quantitative data. Number one in here is not quantitative data because it is the code for the qualitative or categorical data. Is this clear to you?
Yes.
Okay, so data collection required one of the following scale of measurement: nominal, ordinal, interval, or ratio. And ratio and interval is for quantitative data, and ordinal and nominal is for qualitative data. We have two type data, right? Quanti and quali. Quanti or quali. Quantitative is a number, or qualitative is a word, right? For example, boy and girl, yes or no, or is this when you ratings, right? Maybe very good, excellent, for example. And quantitative, it's just a number. So the scale of measurement determines the amounts of information contained in the data and indicate the most appropriate data summarization and statistical analysis. So when the data for the variable consists of label or named used to identify an attribute of the element, the scale of measurement is considered as a nominal scale. Nominal scale. When it is the word, but you don't know which one is better than which one. Yes or no, boy or girl. When it is the word, but you don't know which one is better than which one. Or maybe it is the country for student. Maybe Thái Bình, Nam Định, Hải Phòng, Hải Dương. Maybe it is the variable, right? It is the nominal because it is a word. It is a word, and you don't know which one is better than which one, right? So in this case, it is nominal scale. For the second one, the scale of measurement for a variable is called an ordinal. If the data exhibit the properties of nominal data and the order or rank of the data is meaningful. For examples like excellent, good, and poor. Actually, in here we can rank and we can order the variable. So in this case, it is ordinal because the order or the rank is meaningful. But for the nominal, you don't know which one is better than which one. You don't know Thái Bình, Nam Định, or Hải Phòng. Which one is better? So it is nominal. Next, the scale of measurement for a variable is an interval scale of the data have all the properties of ordinal data, and the interval between values is expressed in terms of a fixed units of measure. I mean that you can divide the information, the data, into some small interval, consecutive interval. For example, for the IELTS test, right? When you give from 26 to 29 correct answer, right? When you give from 26 to 29 correct answer, you will get 6.5. So it is the interval from 26 to 29. You will get 6.5 for IELTS mark. So in this case, it is interval. And for the last scale, it is ratio. When the data have all the properties of interval, ratio, and the ratios of two values is meaningful. Like how old are you, for example. So you can collect the number only. So the variables such like distance, height, age, weight, and times use the ratio scale of measurement. So remember that we have 4 scales for measurement: ratio, interval, ordinal, and nominal. Ratio and interval for quantitative data, and ordinal and nominal for qualitative or the word. Is there any question in here, class? Is this clear to you for the definition from some scale?
Yes.
Yes.
In this slide, we introduce the data sort. You can find the data from public sources and experimental study. And here, when you make the survey, right, you could like to find the average height, or like I just give you some example before. We have observation studies, so you can make the survey and after that collect the data, and you have to classify the data and you have to choose the scale based on your data. For the next slide, I give you some application areas for statistics, for economics, engineer, business, and many other areas. Actually, it's for some areas you need to collect the data and have the whole view for your data. You can find the average and you can make some estimate from your data. So the application of statistics in some areas, it has a lot of application. I mean, yeah. So remember that for statistics, we have two main branch. The first one is descriptive, and the second one is inferential, right? And for descriptive, we have two main branch. The first one is its graphical methods, and the second one is its numerical methods. Graphical or numerical methods. So in the first lectures, we focus on graphical methods for one categorical variable. The first one is tabulating table, or the second one is this graphing table by using bar charts, pie chart, and Pareto diagram. Okay, so when you follow some step in here, we know the way to collect the data. We can clarify the way to collect the data. And after that, when you look at to the table in here, look at to the table in here. Is it the frequent, relative frequent, or proportion? So when you look at to the table in here, what is the variable? What is the variable in here? What we want to focus from the data. When you look at to the table, I have the first column is its class, the second one frequency, and the third column is its relative frequency. So what is the variable in this case?
The number of CEOs.
The number of CEOs, sure.
The
Proportion.
Degree, yeah. So actually in here, the highest degree obtained for the whole population, right? So in here, actually the variable in here is this class of degree for the whole population, non-bachelor, master, or law, right? And after that, for the whole population or for your group, right? This is the number of we have 7 bachelors, 11 master, and doctorate 6, right? So after that, you can find the relative frequency. Relative frequency, it is the proportion, or it is the ratio between each kind of variable to the whole group, right? So it is relative frequency or proportion. It is the ratio between each kind of class in here to the whole. 1 to the 25, 7 over 25. So it is the proportion. So it is clear to you the difference between frequency and relative frequency. For the frequency, you just count, right? But the relative frequency, you have to compare. You have to compare each kind of class to the whole population or to the whole group. Can you see the difference?
Yes.
Okay.
Yes.
Yeah. So when the questions ask you the frequency or relative frequency, be careful, right? Frequency just count, but relative frequency is a ratio. Okay, so we have another example. Identify the variable and its time. Sorry, look back to the example, the previous example. What type a variable? What type variable?
Qualitative.
Qualitative.
Yeah. Qualitative. What about the scale? Sorry. What about the scale for your variable?
Ordinal.
Ordinal, yeah. Because you can order the data. And for the second example, identify the variable and its type. What is your variable in this case?
The variable is major and it's nominal.
It is nominal. The variable is major and it is category or qualitative data. And it is nominal because you don't know accounting, economics, or management. Which one is better than which one? So in this case, it is nominal. It is clear to you? To classify type of data and some scale for each kind of data.
Yes.
Okay. And the count column in here is its frequency. What about the relative frequency for accounting? Can you help me? What is the relative frequency for accounting? Can you type the answer in the message?
0.65.
0.65. Okay, so let me look to the message box. Message box. Only Big Ngọc have the question, have the answer. What about the other? Vũ Thị Hồng, maybe you have to give me the answer as a decimal number. Decimal number. And all of you get the answer. Nguyễn Thúy Hạnh, Y0, camera, 3, 2, 5. To find the relative frequency, you have to find the ratio between 130 over 200. 100 calculator. It is 130 divided by 200. So the answer in here is 0.65. 0.65. Nguyễn Thu Hiền is not 0,65. It is 0 point. Point. You have to use the point. Lê Đặng Huy 0 point. And Nguyễn Thúy Hạnh. Why you get the mistake in here? Can you explain for your mistake here? Thúy Hạnh. Okay. And remember that you have to use point for decimal number. 0 point. Okay, so the bar chart is graphical defined for depicting qualitative data summarized in a frequency, relative frequency, or percent frequency distribution. Okay, so I could like to show you can you guess? Can you guess? Is this frequency, relative frequency? What about percent relative frequency? Is it 0.65? Can you guess what is the percent relative frequency? Percent relative frequency. Can you guess? And type the answer in your box chat. Okay, so I see all the answers in the box test in here is correct, 65%. So sometimes we use the frequency, sometimes we use the relative frequency, and sometimes we use percent relative frequency to present the data.
Miễn điện.
Okay.
Note that we may wish to use the vertical bar chart. Horizontal.
Okay, so the bar chart is graphical defined for depicting qualitative data, summarized in a frequency, relative frequency, or sometimes it is percent frequency distribution. So on horizontal axis of the graph, we specify the label, or it is the majors, management, economic, and accounting. See? And a frequency, relative frequency, or percent frequency scale can be used for the other axis of the charts. It is 50. Let's look back. It is 65% for accounting. And in this case, it's not percent. 20. Is this 20 for economic, right? 20. So in this case, the horizontal line is so the frequency. Sometimes we can use the percent frequency. Okay, so for the next part, is another way to present the data. Is this pie chart? The pie charts provide another graphical device for presenting relative frequency and percentage frequency distribution for categorical data. So when you look at the pie charts, can you use the frequency in here? Can you use the frequency for the pie chart?
No.
Yeah. See? For the bar chart, you can use the frequency. You just list how many people joining management majors, right? You can show the number only. We counting and show it the bar chart in the bar charts. But for the pie charts, we can use the frequency. We have to because the circle in here, the whole circle is 130 360 degrees, right? And this is 100%. So you have to share for each measure. I mean that when you use the pie charts, you have to use the proportion or relative frequency to present the data by pie chart. Okay, so the question in here is when to use bar charts or pie chart, or another ways. What is the difference between the bar charts and the pie chart? What is the difference between two kinds of chart, pie charts and bar chart?
I think that bar chart use frequency and pie chart use relative frequency.
Yeah, it is the first point. What about the other point? You can type your idea in the box task, and I will give you 3 minutes. You can find the information in some sort. What is the difference? And you can type the difference in the box task.
I think that when we use pie chart, you can compare each group to the whole group.
Yeah, this is easy for you to compare. A kind to the whole. To the whole. At the point, actually, when you look at to the pie, to the bar chart, like that, we can know that which one is higher than which one, right? But this is very hard for you to know, to compare each kind for the whole population, for the whole group, right? Yeah, is this the correct point? Other? For FMT, we have 6 major. 6 major, yeah. Marketing, accounting, I don't remember exactly. So for FMT faculties, we have 6 major, and other faculty in Hanu, we have a lot of majors. So when you collect the data from the student, for the number of students joining some majors, joining for each majors, it's a lot of majors in here, right? Account, English, Chinese, like that, and a lot of majors in here, like that. And it is easy for you to use the bar chart in this case. Sorry, the pie charts in this case.
No.
Actually, it's when you use the pie charts in here, it's too many slides, right? You have to divide the circle into a lot of slides like that, and it's very hard for you to look at to the graph and interpret the data, right? Other point. When you look up to the pie charts, can you know exactly how many students joining economics or management? Can you know exactly how many students for each major?
No.
No. Right. See, you just know the proportion, right? You don't know exactly how many people, how many students joining each major in here. So overall, the bar chart is much more information visualization than the pie chart. And in some case, it depends on your situation, right? When you want to focus on the proportion, and sometimes we want to focus on the information for each kind of variable. So based on your situation, you can choose the graph. So if you are not certain whether a pie chart will be good choice or visualization. So I think it's bad to play except with a bar chart or column. Okay, and this is the present data from graphical, and for the second one we can use frequency distribution or stem and leaf display. Now, when I have the information in here, the list of the list of number 15, 16, 21, and it is ordered from the smallest to the biggest. And how to present the data using stem and leaf display. First of all, you have divide each observation into stem and leaf value. Stem value define class. So in here, when you look at to the data in here, it is 2-digit number. 2-digit number, right? So for the stem in here, it is the 10 split. 10 split. And leaf, we focus on 1 or unit. So in here, stem, it is 1. We classify 1, 2, 3, and 4. That's all. It is the stem, or it is a different value for 10 split, right? And for the leaf in here, right now you put the leaf as a one place, and remember that order them from the smallest to the biggest. So I will stand here 1 more minute, and if you have any questions, we can discuss together. Any question? Is there any question here, class? Can I give you another example?
Yes.
Okay, so let's I give you another example. Here we have an example in here. The managers of Hudson Auto could like to have a better understanding of the course of part used in the engine's tune-up performed in her shop. She examined 50 customer involved for tune-up. The cost of part routed to the nearest dollar and list below. So when you look at the example in here, it's different from the previous one, right? Because it is mixed number. It's mixed number, but the previous one is ordered from the smallest to the greatest. But in here, it is mixed a lot of number in here. But it's all. Sorry, it's not all 2 digits number. It's mixed from 2 and 3 digits number. So for stem and leaf, let's do it together. Actually, first of all, you have to order the data in here from the smallest to the greatest for the stem and for the leaf. What is the smallest 10 digits number? What is the smallest 10 digits number?
5.
5, yeah. So I could like to circle number 5 for the second row, for the third row, fourth, and oh, that's all. So for the stem in here, number 5. And what about the sleep based on stem 5?
2 and 7.
7.
7. Yeah. And the next, number 6, right? Number 6, let me cross out 2 number in here. Number 6, the first row, 1. Second row, 2. Third, in the last. Right.
In the second row, 69.
69. That's all. Okay, so it is very hard for you to list and order immediately. So I could like to write this step by step. Maybe in the first line, is it 62, right? So I could like to write 2 in here. Next, number 9 and number 6. Is this correct? For the third row, 2, 8, 5. 2, 8, 5. For the fourth row, 8, 9, and 7. And for the last, it is 2, 9, and 2. So after I write down step by step, so after that I can order. One more step I have to order is from the smallest to the greatest. 1, 2, 2, 2, 2. See? Next, 5, 6, 7. 5, 6, 7. And 1, 2, 8, 9, 3 number, 999. See? So this is the way I use stem and leaf display, stem and sleep plot to present the data. Is this clear to you? And leaf plot. Is this clear to you, stem and leaf?
Yes.
Okay. And when you look at to the table in here, you can see that for the second stem, for number 2 stem, yeah, it includes a lot of data in here. So maybe we say that the stem and leaf mean 2 and 3, 2. A lot of observation have the stem 2 in here. So the proportion for stem 2 is the high gate part compared to the whole population. Frequency distribution table, that you have to determine the range. The range is the difference between the highest and the smallest data. For example, in here, the range is from 15 to 41. The difference, you have to find the difference from the highest and the smallest. And for the second example, the range in here is from 52 to 100 and from 52 to 109. So the range is the difference between the smallest and the highest values. You select the number of classes, compute class grade, determine class bounded, and compute class midpoint, count observation, and assign to class. I mean, is it some step for you to graph the frequency distribution table based on the data for quantitative data? Frequency distribution. Is this for the second for the okay? So what is the scale in this case? What type and what scale? Type and scale. A measurement. What type of data in here, class?
Quantitative.
Quantity. And the scale?
Interval.
Interval.
See? Interval. And when we cut to the first column in here, each interval in here is consecutive. And the distance or the length for each interval they are the same. 50 to 60, 60 to 70, 70 to 80. They are the same. And for the second column, it is frequency and percent. Because it is percent, so you just need to 4. You don't write 4%. Okay. It is a frequency distribution for the data. And yeah, it's just histogram example for the interval. And remember that for histogram, it's U for quantitative data. It's U histogram, U for quantitative, and the difference between histogram and bar charts is when you look up to the bar chart in here, sometimes it's described for quality, but actually you can use bar charts for quantitative data. For example, 7 years old, 11 years old, and 20 years old, for example. Years old. Maybe you can use the bar charts for quantitative data, right? And in this case, we have some space between each bar. We have some space between each bar. But for histogram, no graph or no space between some column, because it is interval data, right? So each interval consecutive, so no graph in here. Beside the column in here, beside. It is clear to you? Histogram and bar chart?
Yes.
Okay. And is it some tip for you to make the histogram by yourself? And I think for some projects, for your project, you can use Excel or R program to make some histogram. in order to make the graph by hand. Yeah. Describing distribution. So when you look up to the to some display, remember that for bar or for histogram, you have to order the data from the smallest to the greatest. All the way order the data from the smallest to the greatest. And when you look at to the distribution, when you look at to the distribution, the data is normal. It is normal. If when you draw the data, it have the bell shape like that. It is a bell shape like that. 50% from the left, 15% from the right. And for the second pictures, it is bimodal. Bimodal, it means that you have two shape like that, two bell shape like that. And for the next one, negatively skewed, or skew to the left. So you can see that in here, the population, the data focus on the right hand side, or the score in here is 25, based on it's focused on the right hand side, and in this case it is skewed negatively. And for the last picture, it is positive skewed. And remember that when you look at to the data, it is have some trouble. It is have some trouble if your data have three kind of shape: bimodal, negative, or positive skewed. And this is normal if it have the bell shape like that. And for the previous semesters, when we make the distribution of your mark for MEB course, your point is skewed negatively like that. Negatively like that, from 0 to 10. It's skewed to the right. It's skewed to the left. So it means that your score is too high. Your score is too high compared to the previous semesters. For the previous semesters, it have the shape like that. For 0 to 10. And it is from maybe 5.6. I don't remember exactly, but it is maybe 5.6 or 6.7 like that. So it is normal. But in the previous semester 1, so your score is skewed negatively. So it means that we predict that some students make the cheatings in the test. Okay. So maybe we have to change the way to make the test in this semesters. So when your data have three kind of distribution: bimodal, negative, or positive, it means that we have the trouble in here. But when the population have the normal or the bell shape like that, 15% from the left and 50% from the right, it is normal. It is normal and it is correct. Okay. It is clear to you, class?
Yes.
Yes.
Yeah. Describing distribution plots, data look for overall pattern, shape, centers, spread, outliers, modality, possible group. Yeah, so when you look at to the distribution, you can see that the range for the whole population range from minus 2.4 to 2.4, and in here, maybe this point is outliers. Outliers is the smallest point, and it's make the distance compare with the other. So maybe here is the outlier because it is the highest or smallest point compared to it make the long distance compare for the other. So when you look at to the distribution, you can see the range. You can estimate the mean, and you can have the overall information for your data. Some guideline on graph provide the main title. Yeah. So when you make the graph, you have to provide the main title, which include the main information, label, the axis. We have the vertical and horizontal axis. So you have to label, right? Try to start both X and Y axis from 0. Avoid distorting data and don't use pattern 3D effect, shadow pictures, avoid excess ink. Is it some guideline to make the graph by yourself? Okay, so is this the last slide for the course, and we have to give you the conclusion for the first lecture. In this lecture, I introduce course objective and requirement. Right, we have attendance for tutorial class. What else? What else?
Projects,
how much percent?
20%.
First of all, for the requirement, we have attendance. How much percent?
10%.
10%.
And remember that, sorry. %. And I just and in my lecture, I will give you some small tests to check your attendance. Okay, and your attendance 10% is when check in your tutorial times. Okay, small test for like first. For the second one, is this project how much percent?
20%.
Then you will work as a group. And the last one is this midterm, 20%. Introduce statistic and its application. Describe type of data. What type of data? How many type of data? What is it?
Quantitative and qualitative.
Quantitative and qualitative. Based on quantitative and qualitative, we have some scale of measurement. What is this?
Nominal, ordinal,
Or
interval, and ratio.
one for qualitative, we have to
Nominal and
Ordinal.
ordinal.
nominal and ordinal. For quantitative, we have
Ratio.
Interval.
and interval. So when I ask you to count the number of car, the number of car in rush hour in Hanoi, for example. So what kind of data?
Quantitative.
And what kind of scale? Number of cars in rush hour in Hanoi. Quantitative
Ratio.
and ratio, yeah. Yeah, so you have to classify type of data and scale for a measurement. And for the fourth step, you have to use the table, the graph. I mean the graph. You have to use the graph. Maybe it is bar charts, steam and leaf plot. You can use graphical methods for describing data. And for this lecture, for the first lectures, I just give you some graphical for one variable. Okay. So it's all for the first lectures. I introduce some basics information, data, how to classify data, and how to graphical. I mean present the data using graph. Okay, so is there any question? Is there any?
Teacher,
Yes.
where can we do a small test for the attendance?
Small test for attendance. I will give you the small test. Maybe in I will choose randomly for the lecture times, for the lecture class.
Yes.
Maybe in the third lecture, I will ask you to make the small test, and don't worry because the small test, you can use the materials. You can use the materials, okay? And I just need to check your understandings and check your attendance. But try the best to give the best answer. I mean the small test, you can use the materials. So don't forget. Don't worry. But I will make the small test randomly. Maybe 2 or 3 small tests based on the saving times for each lecture. Maybe.
Thank you, teacher.
Yes. Is there any question?
Teacher,
Yes.
do we have the soft copy of textbook, because I can find their soft copy in our classroom?
Okay, so I will ask the coordinators. So I will upload the file in the Google Classroom, and you can easy to find. Okay.
Yes, thank you.
Thank you. Any more?
No.
Okay, so if you don't have any questions, we